Sure it's going. Well, you should check the German too, minus 3 plus 0. Okay, so I have control building matrix. What else do you need? There's W matrix. What's that? Now, what's the characteristic equation for this? Yeah, so it's going to be S plus 1, S plus 2. S squared is 3s plus 1. Is that right? Is that right? Yes, no? Yes. W matrix, remember what that is? Okay, so what goes next? That guy there. 3? Then what I have to find? What's my transformation universe? What that was? Q, I think. What was Q? Is that a W times control or control times W? Which was it? W times control. Matrix multiplication. 3 minus 2. 3. Let's do this. Hold the choices. 3 plus 1 is 4. Minus 6 minus 3 is 3, 1, 0. And minus 2. Is that right? This is W. And this is. I'm sorry?
Should it be the other way since we're going to control form?
Is it W times control or control times W for a question?
Control.
Is it control times W? All right. That's what I have to know. So control times W. Minus 2 minus 3. 3, 1, 0. So 3 minus 2 is 1. 1. 3 minus 3 is 0. 1, 0. Is that right? So that's Q. Okay, good. We also need what? Q inverse. What's Q inverse?
Negative 1, 0, 1.
Minus 1, 0, 1. We'll make sure it charges both points. 1, 0, 0, 0, 1. So that's true. Now, to get our A matrix, we take the original A matrix here. And we do what to it? What are we going to do? QA, Q inverse. Parking wheel, check. Yeah, different equations. And we're saying that our new x is q times the original x. Plug that in. Whoops, backwards there. This. Q inverse AQ. Now let's try it. Q inverse 1 times 1 is 0, 1. 1, 0, 1. And it's 1 minus 1 plus 1 is 0. Minus 1 plus 2, 1. 0 minus 1 minus 2. That's 0, 1, minus 1, minus 3. What's the right form? Where we erase our characteristic equation, but the characteristic equation is watch. So I should see in the bottom row negatives of the coefficients of characteristic equations, which we do. And the rest of it is zeros and negative negatives. So, look good. So along the way, we found that the system's also controlled. Take this more further here. I had, let's find the new B matrix. B matrix is 1, 1. Q inverse B is what? 1 minus 1, 0, 1, plus 1. 1 minus 1, 0, 1. So it's what? 0, 1. And A matrix is here. This is a new A matrix. New B matrix. So A times B is 1. And 3. Better still be control, right? But it's hard to see in this 2 by 2 a pattern sort of showing up in these things. In that we have all these ones. That's diagonal, right? And the only ones that really matter are these last bits. 2 by 2 is hard to show that. We'll do some examples of higher order ones. There's a pattern that shows up for controllability. And it means that our controllability form it's really easy to see that it's going to be controllable. It is controllable or not, because basically I have ones and zeros in here, and the last things are all non-zero. Yes, okay, I have a control, it is controllable. So that pattern is noticed. Is this system observable? System here. 1, 0.
C times four.
Then it's what? C times A, right? C times A, which is 0, A, this is -1, -1, -1, -2, which is -1, 0, -1. I did that right. Is that right? Is it observable? Yeah, that's full, right? Okay. Subsystem fully controlled, fully observable, put it transformation to so-called canonical controllable form. Everything is the other side. Questions on this? Yeah.
What does that make it?
This matrix? Yeah. That was the controllabilities for A and B, or transformable. It showed that it's controllable and one form is going to be controllable in the other. But there's a nice pattern in the controllable canonical form of controllability that shows up, and we'll show that later. Yeah.
So it's going from like normal form to observable form and then controllable form to observable form of the same problem, different.
Is it supposed to be C transpose and then A transpose times C?
This observable form can be C, CA, or some people like to put it in this form, C transpose, A transpose, C transpose. They got the same thing.
So if you've already converted to controllable form, is it easier to go from controllable to observable? Or
Yeah, in fact, that transformation is what?
just change.
It's actually a real simple transformation. What's the Q matrix, transformation matrix, go from controllable to observable form? Right. So I have here, controllable form. No, it's the building matrix. I'm working. Erase it here. A prime was 0, 1, minus 1, minus 3. All right. I'll put that in the observable form. Try this transformation. See what happens here. I did this one, right? One. 3. 0. But it should be a row, -3, somewhere in the middle there. Should be -3. We'll convert it to observable form. So the transformation matrix is kind of like the identities of the South diagonals.
That's always true.
That's true. Somewhere it may never, but it should end up in 0.4. Right, that editorial here. We're going to start in next week, actually designing systems. We have all the tools now. About stability, controllability, observability, how to transform from one form to another. On a model system is roughly simple systems model system. With everything to now figure out how to design it. So what tools is to get up to that point, or up to that point. Then we'll do